Hey guys, okay, so this video is going to be about Math 103 and how you can use proper bracketing for the Webworks, because I think the biggest part where you lose time on for Webworks is typing things in. So if you use proper bracketing hygiene, you're actually going to be able to type things in more efficiently and make less mistakes. And then you can also use the Webwork to your advantage by using it to plug in the values rather than solving for it algebraically. So I'll tell you what I mean. So to start off, the first thing you want to make sure is every time you're typing an expression, you want to do an open and close bracket together. So a really simple example of this is, for example, if you're typing sine 4x squared plus 3x, how you would type this would you type sine and then you would type the open and close brackets. And then because we have two terms inside, we would add two brackets like that. And then you would type 4x squared and then 3x subsequently. So this basically just is called like good bracketing hygiene. And what it's going to do is it's going to prevent you from having those missed close brackets. And then what we can do is we can expand this by using empty expressions, which are really good for indefinite integrals. So let's say you have a complicated expression, such as we have two integrals over here. I'll show you what I mean in a second. Okay, so you have this complicated expression here. So actually from here, you're actually able to type this straight into the Webwork. So what you would see is that this first part, we're obviously going to have our upper and lower limits. So we need to make sure that we will consider those. But what I always like to do first is I factor out the constant. So I'll start by typing in just a constant by itself. So 2 over 285. Like this, and then I'll type the close brackets, and this is going to be where the actual integration part happens. We know that x squared becomes x cubed over 3, so I'll just type an empty bracket, cubed over 3, and then I'm going to subtract cubed over 3 again. And the reason why I'm typing it an empty bracket is because I'm going to plug in the limits after, and this will actually help save you time. But the thing is, if the expression is more complicated, you would be able to copy it, Control C, and then obviously subtract it off, Control V, just like that. So that's a good way to save time. So here the limits are 15 and 0. So I'm going to plug in 15 and 0. Again, if it's 0, you don't really need to plug it in, but this just, kind of just helps save some time. Now again, we're going to work on the second expression. So we have this expression over here, and we're going to see that again we have two parts that we want to do, right? So we have linearity, so these are two different things we're going to plug in. So as we type that out, what we're going to get is work on the first part, which is just going to be 2 over 4. Remember, always factor out the constants, and because it's x, it's going to become an x squared over 2. So that's just going to be squared over 2, and then again subtract squared over 2. Now we just need to plug in the limits for that one, which is going to be 19 and 15. And then lastly, we have the last expression. So I'm going to subtract off 2 over 76, which is the constant. Always take the constant out. It helps save time. And then because it's x squared, it's going to become x cubed over 3. So this becomes cubed over 3 minus cubed over 3. And then at this point, I can plug in the limits again, 19 and 15. So a good way to make sure that you've done this correctly is you can copy this, and you can actually use a Wolfram Alpha link. I'll post this in the description, but you press submit, and then it'll kind of let you know. Give it a second here, and it gives 34 over 4, which is the correct answer. So remember that you don't actually have to calculate these things, because if you do all this mental math in your head, you might make a mistake and you might lose marks. So remember, because the Webwork is going to solve it for you, it's actually more productive and more efficient to just type in the answer as whole. That way you won't make mistakes. All right, so this is just another example, which is a bit more complicated. But let's say you solve the whole integral, and then you kind of have this part where you just need to plug in the limits. So you can see that we actually have two expressions here. So we're going to do the first one first. And you'll see here it's not too hard to plug in. This one is we have to divide 1 over... this is where you need to make sure you don't make this mistake. Whenever you have a fraction, always put a bracket on the bottom. If not, it's going to count. So if you don't put the bracket, it's going to go 1 over 9 pi like this, which is not equal to 1 over 9 pi. So just make sure you always remember those kind of brackets. So just to be safe, whenever you're doing an expression, always make sure you have proper bracketing on the fractions. And then 1 over 9 pi, what we're going to do is we're going to add a squared over 2 minus a squared over 2. And then again, we're going to fill in our limits. In this case, they're going to be 9 pi and 0. So that's the first part done. And then now I'm going to subtract off this sort of large expression here. Whenever I have a large expression like this, I like to use the square brackets because that will kind of differentiate where the expression ends and starts. Again, 1 over 9 pi, don't forget the brackets. 9 pi like such, and then I'm going to do my square brackets. So this square brackets is basically going to tell me what my whole big expression is. So because this is a big expression, I'm going to immediately write the upper limit and lower limit. And what I mean by that, it's the empty brackets like this. So we have these two brackets, and this is going to represent the upper, and this is going to represent the lower. So the upper and the lower, you're basically going to be typing 9 pi and 0, right? So what you can see here first is, because it's the upper one, I'm going to type in this expression first, which is x sine 4x over 4. So I'm going to have, instead of x, I'm going to write an empty bracket times sine, and then here I'm going to have a 4 multiplied, again, by, it's going to be an x, and then I can divide this by 4. I don't have to put the brackets here because 4 is just a standalone number. And then I have to plus cosine, again 4 multiplied by an empty bracket, and then over 16. So at this point, what you would want to do is you would want to just copy this expression because we're going to reuse it. And then now I can type in the upper limit, which is going to be 9 pi, 9 pi, 9 pi, and then I'm going to plug it, I'm going to paste that thing I copied, which was the same thing, and then now I'm going to plug in 0. So this kind of just prevents me from making a lot of mistakes. I'm going to copy this entire expression, and when I plug it in, it should give me the correct answer. So remember, yeah, you can use the Wolfram Alpha to test if you're typing in these brackets correctly, and we get 9 pi over 2, which is the correct answer. All right, so here's another problem where we're going to use the proper bracketing and the copy and paste function to save time. So if you guys have watched the DI video, I'll try to link that in the description or in an annotation. We can use the DI method here to solve the integral. So we're going to type DI, and then we're going to use the termination side for the polynomial, 6x, 6, and then 0. And then obviously for the integral side, we have all the e to the x's. And then remember that we want the last line to be 0 if possible, because that'll help us terminate the integral. And then we're going to go plus, minus, oops, and then plus, and then we're going to be pairing it diagonally. So when we have that, what we're going to do now is we're going to write our expression, x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x. And then at this point, we still have to plug in our limits. So what we're going to do is we are going from 5 to 10. So what we're going to do is we can actually type out our whole expression first. What I'll notice about this expression, though, is there's an e to the x in every term. So I'm just going to write that on the outside, and then I'll type it in. Okay, so now that we have this whole expression, I can begin to type it in. And again, I'm going to do e to the power of empty brackets and then I'm going to use square brackets again for the large expression, and then I have this cubed minus 3 times something squared plus 6 times something minus 6. And then this is going to be our whole first expression. So I'm going to copy it, and then I'm going to plug in my limits, which is going to be 10. And then now all I have to do is I have to subtract off the lower limit. So I'm going to paste, and I'm going to put in 5 for the lower limit. And then now this whole expression should be able to be evaluated. I'm going to copy and paste it. Like normally at this point you would plug it into the Webwork and then plug it in. And then this is the answer you should get. All right, so the last thing that I want to go over is just some keyboard shortcut keys. If you hold Shift and use the arrow keys, you can actually select a certain expression. And if you press Home, let's say you're in the middle here, Home is basically going to get you to the left side of the text box, and then End is going to be to the right side of the text box. So you can go from the end to the beginning, and then this is kind of the most important one. It's going to be holding Control and then the arrows. So that goes to the closest number / word. So notice how it skips brackets, and it's kind of a fast way to navigate between. So it actually goes from the front of a number to the end of a number. So you see here 10, it's like from the beginning to the end. And that's basically a quick way to jump between your expressions. As well as if you hold Control and Shift, you can select while jumping between numbers. Remember that when you hold Control, it will skip the brackets though. So all of this will be provided in the free PDF if you want to read it over. I'll put a link in the description.